So last week I did a video on how to find the AWS Account ID of an S3 bucket that you have limited access to. This was based on an article by Bridts. The main idea was to iterate through each digit of the account ID and check access to the bucket. One of the requirements of this approach is that you needed to have access to the bucket already. So it could be some kind of a limited level of access, like just to download a specific object, but you still needed to have access to that bucket. Now this video goes into the details of an approach that requires no access to the bucket. You just need to know the bucket name. Like the last two videos, this one is also based on research and writings by a security researcher, Sam Cox, and the link to the article written by Sam is in the description. Sam's idea is to follow the same approach as Ben's, iterate through the account ID digits and check access to the bucket. However, since you wouldn't have access to the bucket necessarily, you can't rely on a simple access denied message you would get when you make an API call. So Sam proposes to use the existence of a CloudTrail entry instead of that API response that you would normally get. It's a brilliant approach. Let's see how it is done. Briefly described, Sam's proposal is to introduce an S3 interface VPC endpoint to a VPC and make API calls from within the VPC to the target S3 bucket through that endpoint. So if you're not familiar with VPC endpoints, they're essentially a way to keep traffic going from your VPC to the AWS services private. Now, if you don't use a VPC endpoint, that is usually the normal case, if you make an API call to, say, S3, that API call would exit from your VPC, go through the public networking, and come back into AWS S3 API endpoint. So there could be issues, there could be concerns about your traffic going through public internet, the untrusted network. So if you have security concerns, if you have compliance concerns in your project, you should probably use VPC endpoints. Now, we are using a type of VPC endpoints called an interface endpoint. The other type is called gateway endpoints. Now, we are using interface VPC endpoints because that allows us to set specific endpoint policies so that we can restrict access based on a specific account ID. So if you used gateway VPC endpoints, you can't really directly apply policies to the endpoint. You can work around that by using IAM policies for the specific role or the user, but it makes things really easy if you just use an interface endpoint. So the core premise of this idea is if you make an API call to a bucket that you don't have access to, and if you see that API call in your CloudTrail log, that means your request was denied by the target bucket because of the bucket policy. Now that means the request actually went through the VPC endpoint because the target account ID matches the policy pattern that we had applied to the VPC endpoint and actually got denied when it reached the target bucket. And that means the account ID pattern that we were testing in that specific policy is correct. So we can proceed to the next digit of the account ID. So access denied message in CloudTrail means we are on the correct path. On the other hand, if the VPC endpoint denies your request based on the endpoint policy, that means the account ID pattern that you put in the policy is not the correct one. And when the VPC endpoint denies an action based on the policy, you wouldn't see an entry in CloudTrail. So again, if you see an entry in CloudTrail, that means you're on the right path. If you don't see an entry, you need to test the next iteration. So to test this idea, let's set this design up in two accounts. Like the last time, I'm going to use two accounts, the main account and the prod account. Prod account is where my bucket would be. The prod account ID is what we are trying to find out from this approach. I'm going to use the same S3 bucket that I used for the last video, but I'm going to remove the bucket policy statement that allowed me access from the main account. So in our case, we don't have any access to the bucket. Before we proceed, we need to know the region the target bucket is in because we need to create a VPC and a VPC endpoint in the same region. For this, you can simply make a GET request to the bucket host endpoint and check the response. AWS sends a response header called xamsbucket region that contains the region the bucket is in. Now, honestly, I'm not too sure if this is a good thing. Now, the region the bucket is in isn't sensitive data, but I'm not too sure if AWS should be exposing that metadata based on a request made only by knowing the resource name. I think this is exposing too much data, and I don't really see a need for this header to be present in this response. But there could be a historical reason. There could be some point in the past that required this response header to be there, but we are going to use that anyways. So back in the account that I'm going to make requests from, I'm already in the target region, so I don't have to switch to anything. I'm going to use the default VPC for this test, but if you are doing this in real life, you should probably use a dedicated VPC. Now we are going to create a VPC endpoint, so that's going to route all the traffic from the subnets associated with that VPC endpoint through the endpoint. So if you use the default VPC, or if you use a VPC that you're already using for production purposes, that might actually break your system. So if you're testing this, just make sure you're testing this on test accounts. I'm creating an S3 interface VPC endpoint and attaching it to all three subnets. I'm also using an existing all allowed security group to keep things simple, but be warned that you should never do this in real life. Don't use security groups like this. Don't trust traffic that is coming from or even going out to untrusted networks like this. I'm just keeping things simple. I just want to get through this step. It takes some time for the VPC endpoint to be provisioned. After that, we need to start making API calls from within the VPC. We can do this from any compute runtime. It could be EC2 instances, an ECS container, or a Lambda function if you have things scripted. I'm going to launch an Ubuntu EC2 instance for this test. Again, keeping things simple. Just going to use the same security group I used earlier, because I don't have to add additional rules to trust traffic between different security groups. Now that the EC2 instance is launched, I'm going to SSH into the instance. Remember that we did not attach a specific policy to the VPC endpoint yet, so it allows all the traffic going through it. It doesn't test for the target account ID. Let me do a simple API call to the target bucket. We should get an access denied message from the API response. And since the VPC endpoint allowed that request, we should see an entry in CloudTrail. After a few minutes, we can see this CloudTrail entry for the get bucket ACL call that I made. If we go inside that entry, we can see that the response is a simple access denied. Now we got denied by the target bucket policy. Now let's start this experiment. Let's go and modify the VPC endpoint policy so that it restricts S3 calls based on the target bucket owner account ID. Now we are using S3 resource account condition that we used the last time. After saving the policy, let's give some time for the policy to be applied correctly. It takes about 5 to 10 minutes for the VPC endpoint policy to be properly updated. After about 5 minutes, I'm making the same call. Now we know that the target account ID does not begin with 0, it begins with 8. So this request is going to get blocked by the VPC endpoint policy. Like I said in the beginning, if the request gets blocked by the VPC endpoint because of the policy, we wouldn't see an entry in CloudTrail. We can see that's the case because even after 5-10 minutes, we don't see that entry. Now let's go and modify the endpoint policy again. This time I'm going to skip a few steps and just test the account ID to see if it is starting with 8. We know this is true, so the request goes through the VPC endpoint, the policy doesn't block it, and we should get an access denied message in CloudTrail event history. After waiting some time for the policy to be applied, I'm making the API call, and after a few minutes, we can see the CloudTrail event. Now this is basically a couple of iterations of what you have to do to figure out just one digit of the target AWS account ID. You have to repeat this for all 12 digits. It's about 120 worst case modifications for the policy if your account ID actually turns out to be 12 nines. Now this would take significant time because you have to manually edit the policy, you have to wait until the policy is applied correctly on the VPC endpoint, you have to wait until the event appears in CloudTrail because it takes some time for the event to appear. In his article, Sam goes into details on how he was able to cut down the time taken to go through this process by using role session names, using binary search and all that good stuff. Now role session names is an interesting case. In the STS assume role API call, you specify a role session name that basically ends up being part of the username that appears in the CloudTrail events for the API calls that you make using that assumed role. So you can use that and the AWS user ID condition in the VPC endpoint policy to make several API calls at the same time with different role session names and test for different account ID iterations at the same time. So with this approach, Sam is able to cut down the time from about 8 hours to just about 10 minutes. So it basically comes down to 10 minutes to actually find the account ID of a bucket that you don't even have access to. So this is where I would usually start rambling about why AWS account IDs shouldn't be treated as sensitive data, but I'm going to save us some time and skip that because I've done that twice already. This is the last of this short series on how sensitive AWS account IDs are, but I hope it is enough for you to start thinking about this in detail. If you enjoyed this video, please take some time to like, comment if you have any thoughts on this. Please subscribe if you haven't already. I'll be making videos on similar topics in the future. But for now, that's me. Thank you so much for watching. I'll see you next week.